Welcome to testRigor. And today we will be talking about a couple of different ways how you can do autonomous testing and test generation in testRigor. So first, I'll show you, I guess, probably the best way to show it is on a mobile application, and then I'll show additional ways how to do it. So first of all, for testRigor, there are two ways which testRigor supports on how to generate tests for you. So one is based on an intelligent crawler, which will use AI to go through your application and to figure out what tests should be created. And number two, you can deploy our analytics library in your production. And testRigor will get analytics about how your users are using your application and use that data to automatically generate functional end-to-end tests, matching most frequently used end-to-end scenarios. Okay, but first we will start from a simple example on mobile application on generating tests. So simple mobile test generation, and we will do native mobile and we'll generate a tests, and let's use Galaxy, and we will get an application. I am uploading this application right now. All right. So when, as you noticed, when we were creating the test suite, I have left an option to automatically generate up to 10 functional end-to-end tests. The actual number might be lower than that, depending on different factors when the system will decide to go through for certain areas or not, and how many tests it will generate. There are, of course, a lot of different settings to fine-tune that, and you can generate huge number of different tests. In general, testRigor will try to prioritize the new paths where it did not go through yet in order to maximize coverage as much as it can. All right, so what's going on right now is basically, since it is a mobile application, testRigor starts a new instance with mobile native mobile emulator. In this case, I think we have selected Samsung, and then it would upload. It will start the emulator. Will download the APK, upload the APK into the emulator. Will start the emulator. Start the application, and then we'll try to go for this application. And as soon as tests are ready, they are added automatically. As you have seen, it was one added, and then after some time, the second one, and we'll expand that, and I'll show you how does it look like. So basically, here it's a very simple application, quite trivialistic, as you can see, and there are just two buttons in there. I'm ready and about, and the first test just basically clicks on the first button. then on a second screen, on second button, and on a third screen, it will stop automatically because there is no more actions available on the screen. And the second one is basically once it's clicking on a second button, it's getting in a situation when there is no actions available. And of course, if you have different inputs and different ways to import information, it will import information before clicking on the button on the screen. So this particular approach works best on mobile applications. Why? Because mobile applications have limited interface, and therefore you can actually generate a lot of meaningful tests. It is order of magnitude far more complex with the web, and the interfaces contains tens and sometimes hundreds of different actions to do on a page, on every single page. So it just might not be, so the crawler might not be able to pick the right action on certain steps, and therefore might not prioritize the flows which you might consider as most important, although it tries its best. So now let me show you another example, and I'll talk about the generation. So let me the capturing on errors specifically in this mode. So if we will create a new application, and call it test automatic tests. We'll use this simple URL in there, and let's generate some tests. In this case, it will work a little bit faster because this is web, so there's no need to download and upload APK, and the application is trivial enough in order for us to be able to catch that. Okay, drum roll. We should get the first test generated for us soon. So even though it is a mobile application, the UI in this particular application, as a sample one, is ultra trivial. It has just one input and one button. So that testRigor generated test where it enters the data into input and clicks button. And then it basically, as you can see, the text above changes in there. So now let's open up this application, and this is how it works, right? So you enter something here, click update button, it updates here. So let's imagine that we released a new version of application that has a new button in here. However, if you input it data in here, click update, nothing happens. It doesn't update its text anymore. So let's see if our system can catch it up automatically. As you can see, there is no explicit validations here. Okay, if we go here and we use a change URL instead of doing something else, but in your particular case, you probably would have deployed a new version in production. Let's do the run. So basically, it runs the same test, but it uses different base URL in our case. And it was pretty fast in here. And as you can see, it went and it did the same actions. And when it detected that the text is no longer on the screen and highlighted it in red in here. So this is one. And second part, interesting part about automatic test generation, if you have 10 tests, specify 10 tests, and number of tests is lower than 10, right? Lower than you requested it to generate, when it will generate additional tests as soon as it sees additional functionality in there. And you can see the results in a tree view, how it goes through different buttons. And as you can see, it clicks different messages. And here you can see the screenshot in this tree view on how it goes through your application. Now, if this is cool and all, how can you control that for this particular test generation technique? It's all in the settings. Then I believe in retesting. In retesting mode, you can control how you generate errors. We would only check a last page to compare text inputs and buttons, but you can validate on every page. And you can basically control what is being validated. By default, it's everything, and both texts, all kind of inputs and all kind of links and buttons in there, and all kinds of lists. And I believe we have somewhere a way of specifying maximum number of tests. Yeah, it's somewhere in the settings. Okay, yeah, there's a special tab in here. It's exactly called test generation. And as you can see, there are two of those which I was talking about. And specifically what we're dealing with here with is crawler-based test generation. And this is where you can control the number of tests, maximum number of tests it will generate for you, maximum depths it will go into, and so on and so forth. There's quite a number of different options available here out of the box. Anyway, so this is one way of doing that. As you can see, it works really well on pretty simple applications and all mobile applications. However, on complex web UIs, it might not do a good job just because the number of different elements on the screen is gigantic and might not necessarily guess correctly which one to click in which case. However, so we have another way of generating tests, as I was mentioning. There is a way to automatically generate tests based on how your users are using your application. And for that, you can copy paste that script, which we provide into your page on, like, usually it would be in the footer of every single page. As soon as it's on every single page, then system will be able to continue and process it. So basically, it will not capture what your users are inputting in your inputs. However, it will gather information of what flows your users are taking in a similar format as you can see in a tree view, although it will not be presented to you in a tree view format. It's just will be completely internally. And then Once it is done, you'll start getting tests generated. If there is enough number of users going for certain flow, then it will be prioritized, and then tests will be generated in the order of most frequently used flows in there. It's a long process, it's multi-step process, and it requires enough certain number of data in order to be able to even kick in. But if you do have enough traffic on your website, you can leverage that and get yourself tests generated. Okay, so let me switch to answering questions. We have desktop-based trial versions. Is it so based storing? The desktop-based trial version. Okay, so Kiran asked, is desktop-based trial version? There is no such thing for testRigor. testRigor is SaaS. You can get there online. You can deploy it on premise, and we have a number of customers which do that. However, it will be deployed in your network as internal SaaS. So there will be some kind of a internal website in your internal VPN network where you'll be able to access your internal version of testRigor. It is not a local desktop application. Next question is, very recently I have tried automating Tesla car purchase. I was able to automate further since page was divided into screens. Static and as a dynamic is changing. How do we approach this situation? Well, it's a generic question, nothing to do with test generation, but let's do that. In testRigor, the instructions which you specify in testRigor do not rely on details of implementation. So whatever you instructed to do, it does not matter if the section is dynamic or static, it will just work. So let's go to tesla.com. Okay. Where is this? And let's do Tesla. Get a number. We will not generate automatic tests there in this particular example to speed things up a little bit. And let's, I guess, in order to be able to get to dynamic forms, you need to purchase something. Let's purchase model free, I guess. Let's click on model free. Order now. I want to see purchase price. I want to select performance. What else? And blue. Let's add full self-driving. And click continue to payment. Click order where's the card. And enter some data in here. And I'm not going to finish this form. I just enter some additional things and I try to click placeholder. It's not going to work, of course. All right, so let's do Tesla here and call it purchase model free. Anyway, let's simplify a little bit. Click model free. Click order now. Click purchase price. Click on blue Let's just say we want a blue, add, continue to payment, order as a card. Oof. It detected that the URL changed, but we don't care about that, and we don't need to click on the first page. Okay, so as you can see, we clean it up. So when we're recording a step, it's also detects the URL changes, so it updates that. We don't care about this. We just specify it, what needs to be done, and when we click, oh, what is this order now? Place order. Okay. Place order. All right. We added that. This is our Tesla. This is our test with clear steps. So testRigor is basically executable specification engine. You just write specification in English how things should work, and it will execute it for you, emulating how a manual tester will do that. Here, click order now. Purchase price as I wanted to, and I want a performance and blue. Oh, everything is blue in here. So we need to, I guess, specify blue metallic. So let me, so when you specifying, different things like this, let's call it deep blue, I guess, deep blue. When you're specifying clicking on certain elements, you need to rely, you should try to rely on something which is visible to end user. In this particular case, if you hover over, there is a tooltip visible, and it says deep blue metallic. This is what we can rely on. Or order with the card is not available. After we click continue to payment. Okay, so this button, I guess, is not available. So before continue to payment, we need to scroll down. Scroll down. Also, instead of blue, let's do deep blue. Go. So as you can see, it's just a more or less straightforward process. You just look using screenshots what didn't work and adjust accordingly. You do not usually need to look into any details of implementation. Moreover, you should not. If you want to keep your tests as stable as it's technically possible, your best bet is to let go of any details of implementation and just rely purely on specification, how it should work or look from end user's perspective. All right, even deep blue actually is this the whole large element. I guess we need to scroll down before deep blue. Oh, yeah, it's another thing which we didn't do. We need to scroll down. And another way to force to click on a certain element if it tries to select a larger one is sometimes smaller element are larger, a part of a larger button, and the whole thing is a button. you can force it to click specifically on that one by saying deepest element. There we go. Anyway, so we have other questions. How you manage timing to wait for next page if it fails to find element? Is default time wait before failing. Documentation that you have complete or required feature required to automate your flow. Yes, our documentation contains all the commands. Any area is still under progress, so we are creating more documentation as we go. But let me talk about timings. So if you go to settings, and speed optimizations, there is a huge number of different things you can adjust in here, as you can see. So by far, number one, the most important one is maximum wait timeout, which is by default 30 seconds. What does it mean? Is the system will wait up to 30 seconds. It's gonna wait 30 seconds every time, but it's up to 30 seconds until element is visible and available for interaction on the page, and then it will interact with that element. So this is one. Second, on top of that, by default, you can turn off this behavior to speed things up. It will wait until page will stop loading. You can wait until all the scripts are done executing on the script, and there's tons of different other options you can meddle with for performance optimizations. Okay, let's see where we are here. Okay, so it didn't scroll because I guess you don't scroll on here. You scroll on this part. And let's try to record it. Nope, it didn't record it. Anyway, let's inspect. Okay, there we go. Scroll container. So scroll down on scroll container. I guess the same thing would be in here as well. And we can scroll down until page contains paint. In this case, scroll down until page contains this one. All right, there we go. So basically, apparently, it's not just scrolling on the page, because by default, it will scroll the whole page, which is not scrollable. We need to scroll on the side element. And you can scroll until you get to a certain element. All right. Yes, so we just, the question was, can you specify, can you scroll up to a certain element? This is exactly what we did. You can scroll until you get to a certain element.
All right, should we wrap up this session? We're a little bit over time. The next session in 2 weeks will be how to test iframes and shadow DOMs. So we hope you guys will come back, and I'll be sending out the recording for this. Thank you so much for joining us. There's a question there, Artem, about apart from the documentation, what are supported by testRigor team if run into issues?
All of our paying customers have a direct channel of communication with us. We support them directly on Slack and on MS Team, and you can create Zendesk tickets. So please request a demo or send us an email to basically set up a trial so we can set up your communication channels for you, and we'll be able to answer your questions quickly.
All right, thank you.
Thank you very much.